In today's video, we are in Chapter 8. We're doing the second part for association claims and looking at the 4 validities. So this is pretty exciting because this is the video where you learn once and for all, correlation does not equal causation. That is a mantra that any research method student, any psychology student should have just emblazoned on a t-shirt. Correlation does not equal causation. That's in our textbook terms saying an association claim is not a causal claim. And you're going to find out why by the end of the video. So to start off, we're going to look again at these 4 big validities that we talked about before. And we're doing it in terms of association claims. So, well, let's remember those 4 big validities. Construct validity. Now, this is pretty much the same for any kind of claim. And the first thing is, how were the variables measured? Okay, so what were the operational definitions? Now, if the operational definition for a correlation or association was some kind of survey, well, now we've learned there's a lot that goes into, is it a good measure? We have all sorts of kinds of reliability, the face validity, which is kind of silly, content validity, test, retest. What are the ones? Look at table 8.5 is a great one. It's got criterion, convergent, discriminant. All of these things go into the question of construct validity. So there's a lot that goes in here, but it's nothing particularly special to correlations. This is true of any kind of study. So we're just going to move on now. Statistical validity. We're going to hit definitely that in a little more detail for how does it relate to associations and correlations. Internal validity. This is the big one for correlations. This is where you get to figure out why correlation does not equal causation. So we'll hit that hard. The 4th one, external validity, pretty much the same for any kind of study, any kind of claim. It's just, okay, you have the sample of people that you got data from. Who do they represent, right? Who, we make some conclusions about the sample. Now, what other people can we generalize to? What other situations can we generalize to? That's a question of external validity. It's really no different in any kind of study. So let's take a little bit closer look at statistical and internal for how they particularly, relate to correlations and association claims. Well, the first kind of big thing with statistical is like, okay, so there was an effect, but how big? Now, in a correlation, all right, we have a correlation coefficient. There's some kind of association, but how strong is it, right? Is it weak, medium, strong correlation? And the correlation coefficient tells us this. So that's great. Now, moving beyond the strength of the correlation or the association, we also want to ask, but is it a statistically significant one? Now for this, we're going to get something that gets spit out from the SPSS or any kind of computer stats package we use called a p-value. Now p-values are actually very important and I want you to understand them. I have my own video on this that's talking about p-values and experiments. I actually put up a link to some other guy's video that I think's pretty good. He's very outgoing in his videos, so maybe I need to up my game. It's about 10 minutes. Go check that out. Hopefully we'll hit p-values a couple of times just so they really are good. Now in his video, he's talking about p-values for experiments, but the same applies to correlations. And just say, the p-value will tell you, all right, you got a correlation coefficient of 0.30, or you got an R of 0.7 or 0.5 or 0.219, whatever it is. You'll then get a p-value and say, is this statistically significant? Okay, and so check out the p-value video to look at that. But these are all questions about statistical validity. Are these things that we would see just by chance, or is there something real going on here? Okay, now the other things that have a sort of a special issue in association claims. Pay attention in your chapter to some of these things that can mess up a correlation. Outliers, we already covered that in the earlier video. Restriction of range, did we only take a sample of people that aren't giving us the full picture? And would the correlation or the association between these variables hold up if we got the full range of people on some measure? Okay, if we look at something, let's say we look at shoe size and height, and I expect that the taller you are, the bigger your shoes will be. But I only look at people that are, 5'8" and taller. And I find, there's really no correlation here. Well, it's because I have such a restricted range of data that it's not going to come out. If I get from everybody from the tiniest, shortest people I can find all the way up to these NBA basketball guys, yeah, I'll probably find my correlation. I was just looking at a little bit of the range of the data, but if I look at everything, oh, maybe it'll be there. And the opposite can happen. I could look at a restricted range and find a relationship that disappears once I actually look at everybody along that variable that I'm measuring. Curvilinear, that's a funnier one. It's like, well, what if instead of I'm only looking at one piece of the picture and I have this sort of funny view of reality, what if reality is things, they're correlated together and then they start going down, okay? I think a really good example, your book has an example of this. It'll come to me. What if, I don't know, let's say sleep deprivation. The longer time I go without sleep, let's say as the number of hours without sleep goes up, my energy level goes down. But then let's say there's this weird thing where at a certain point, I actually start getting really hyper and my energy goes up, strangely enough, and then it crashes again. I would have this weird, like as the things are moving, they're going like this, and then they're going like that, and then they're going, okay. So that would be some kind of strange curvilinear relationship that's gonna, again, it may, if I get the whole range and I plug in my numbers, I might get like a zero correlation because the average of this is just sort of zero. And I'm missing something. And one way to guard against this is researchers always need to actually graph their data when they're doing association claims, particularly correlations where both your X and Y are a continuous variable. And you want to see, what does it look like? So I can just inspect visually, ooh, is it doing this? Okay. So you have to look out for that. So these are the special things that kind of come up with association claims in statistics. Now let's get to internal validity. Internal validity really is asking, have we controlled everything in this experiment in a way that I can make a cause and effect claim? Can I do this? And there are two reasons why I cannot claim causation from correlation. Now let's look with this slide. We just want to view, what do we need for causal claims? Well, the first thing we need is the two variables need to be correlated. They need to covary and sort of have this predictable relationship. And we actually have that in association. In fact, that's what we have is a covariance. Yes, we can predict as this increases, this other one decreases. Or as this increases, the other one comes with it. Okay, so there is covariance in a causal claim, but it's not enough. The next thing we need is temporal precedence. One has to come before the other. Now, sometimes we actually have this. If I say, you know what, there is a pretty strong correlation between your high school GPA and your college GPA. Well, which one came first? Well, you had to have the high school GPA before you earned the college GPA. So in that association claim, I actually do have temporal precedence. Okay, I do know which came first. Now, in other association claims, we don't have that. We don't know which came first. Let me see. So I'm looking for an example on this. Well, here, I'll give you an example here. Directionality examples. Okay. Okay, the other thing, let's say if we don't have the temporal precedence. Let me just check my slide here. To do temporal precedence. Okay. If we don't have it, the other thing about this is sometimes we see associations because the two variables we're looking at actually are causally related. One causes the other. Now, sometimes this is true. So sometimes the association is there because of this underlying causal claim, causal connection. The problem is because the way we collected our data, we don't really know if it's cause and effect. Now, one of the reasons we might not know is because we don't have directionality. We don't have temporal precedence in a lot of the things we do measure. So here's a couple examples. One of the things off your worksheet said the more depressed people are, the fewer friends they have. Okay, that could be cause and effect. Now, I don't know because all I did is went out and measured two things. I asked people, how many friends do you have, and fill out this depression scale. And I put the data into equation and I went, poof, oh, there's a significant correlation, a significant relationship there, some association. Now, if it was cause and effect, well, then the question would be, well, which came first? What's the temporal precedence? Are you depressed because you only have a couple of friends, you don't have very many friends, and that makes you depressed, that causes the depression? Or maybe the reverse is true. Maybe because you're depressed, you're a real bummer to hang out with and nobody wants to hang out with you and you don't have any friends. Okay, either of those directions are plausible causal relationships. It's also plausible that it's completely not caused one by the other and there's something else going on that causes both of these things to be true. That's the third variable problem, which comes next. But let's look at the next one's probably a better example. Let's say we ask students all sorts of questions and we discover an association between the number of clubs that students say they're members of and how happy they are with their college or university. There's a correlation. The more clubs you join, the happier you are. Okay, that would be positive correlation because both things move in the same direction. The fewer clubs you join, the less satisfied or happy you are with your college or university. And now think about it. Someone at, in student affairs is going, oh my goodness, we should really make people join clubs because that's going to make them all happy with their university. They're assuming maybe there's a cause and effect relationship. Well, one of the reasons we cannot claim that is because even if there is a cause and effect underlying this association, the question is, which came first? Is it that students were like, it's okay, and then they start joining clubs and they have fun, and then they're like, wow, I love this place, I'm really happy. Does the actual joining make you happy? Or could it be the reverse? Happy people tend to go out and say, hey, this is great, what can I do? Oh, look, drama club, fun. Oh, chess club, awesome. And so maybe they do that, and it's the happy students that go out and seek the clubs. We don't know which came first because we just measured both things at the same time. You can remember this as a chicken and egg problem. Okay, I've got one more thing to talk about, but I'm going to stop the video for just a second, and there'll be a second part of this video for you to look at so we can finish up the chapter.